I'd like to use a system of equations to solve an application problem. The area of a rectangular piece of cardboard is 216 square inches. The cardboard is used to make an open-top box by cutting 2-inch squares from each corner and turning up the sides. The box must have a volume of 224 cubic inches. Find the dimensions of the piece of cardboard. So I don't have a piece of cardboard that has exactly the dimensions we'll end up with, but I'll use this note card to get started as an example. So I have a rectangular piece of cardboard or a note card, and I'll make a box by cutting squares off of the corners. Now the squares are supposed to be a particular measurement of 2 inches in our actual example, but on the note card, I'm just going to try to cut off the same size square each time. And so probably not going to manage to do it perfectly, but that's okay. So there's one square. So just cutting a square off each corner. And you could imagine that if you were going to make a metal box, you could cut squares off and then use a weld on the seam to have made a rectangular box like this. All right, my squares are getting worse as I go around it, but it's still okay. Just getting the idea here. So when I'm done and I've cut these squares off the corners, I see this plus shape. And to make the box, I then fold up the flaps that were formed, these sides. And then since I'm dealing with paper here, I could imagine taping the sides together to have a box. All right, in the shape of a rectangular prism. One thing to notice is whatever the side lengths of the square I cut off was, that becomes the height of the box. However deep I cut in, when I fold that up, that's that vertical height. So let's see now if we can go back to this problem. So I have a piece of cardboard with some length and some width. And so let's just call the length X and the width Y. Now I chose those variables. You could choose to use L and W. You might even choose X and Y, but have them swapped. Hopefully we'll end up with the same dimensions. Then I'm going to imagine cutting squares that are 2 inches by 2 inch off each corner. So the squares measure 2 by 2. And folding up those edges to get a box in the shape of a rectangular prism. And what we just noticed was that when I fold up this flap, this length here became the height, and that's 2 inches. So now let's see if we can find the other measurements of the box in terms of our chosen variables. So this whole length was X, but I took 2 inches off each side, so that's going to be X minus 4 long. This length started off as Y, but again I took 2 inches off the left side and 2 inches off the right side, so that will be Y minus 4. So I need two equations. And I know something about the area of the original piece of cardboard. It was 216 square inches. Well, the area of a rectangle, that's length times width, so that would be X times Y equals 216. And then I know something about the volume I'm supposed to end up with. The volume is supposed to be 224 cubic inches. So length times width times height is supposed to be 224. So 2 inches is the height, times X minus 4, times Y minus 4 equals 224. And now I have a system of equations in two variables that hopefully we can solve to find X and Y, the dimensions of the original piece of cardboard that we're asked to find. So let's rewrite the system of equations and just try to solve it. And before I even get started, I noticed that that second equation, both sides are divisible by 2, so I'm going to divide both sides by 2 just to make that equation a little easier to deal with. You don't actually have to do that, just something that's nice to simplify the equation a little bit. So I have a system of nonlinear equations. I don't see a way I could add them together in a meaningful way to get something to cancel out, so we'll proceed with the substitution method. In this first equation, I'll solve for y. y is equal to 216 over x. And I'm going to plug that into the second equation. X minus 4 times 216 over x minus 4 is equal to 112. Now I have one equation with one variable x. Let's find x and then see if we can use that to find y. So I need to distribute. So x times 216 over x gives me 216. So now x times minus 4 gives me minus 4x. Minus 4 times minus 4 gives me 16. And then finally, the term I'm missing now is the middle one there. So minus 4 times 216 over x is minus 864 all over x. And that's still equal to 112. I have two like terms, 216 and 16, which is 232. Minus 4x minus 864 over x equals 112. Well, let's see. Let's take 112 away from both sides. We'll have 120 minus 4x minus 864 all over x is now equal to 0. Well, to make this equation simpler, let's multiply everything by x, clearing the equation of that denominator. And so now I see a quadratic equation. Minus 4x squared plus 120x minus 864. I'm going to divide everything by minus 4. So I'll get a positive x squared minus 30x plus 216. I could use the quadratic formula, or I could factor. I'm going to choose to factor it because I happen to know that 216 is 12 times 18. 12 and 18 add together to give me that 30. So I have a minus 12 and a minus 18. Telling me that x could be 12 or x could be 18. These were measured in inches in our original problem. Well, those are x's. Excuse me, both of those are x's. X is 12 or x is 18. Going back to our original system, we had an equation that said y equals 216 over x. So if I divide both of those, I get y is either 18 or 12. And so I realized that the way I drew my picture, x is the longer of the two dimensions and y is the smaller. So I'm going to report that the dimensions are 18 by 12. And if I swap them, I'd still get 18 by 12. I'd get those same dimensions. If you use different variables, you're still going to get two options. It's either 12 by 18 or 18 by 12, and we realize that that's just a matter of how we're holding a rectangular piece of cardboard. When you go into MyMathLab to do your homework problems, it's probably going to tell you that one of the variables, x or y or L or W, is the long dimension, and that's so you can enter them into MyMathLab and it can check your work. In the actual application, as long as it's 18 by 12, it doesn't matter how we hold the rectangle. So pay attention in MyMathLab so that you enter your answers incorrectly, but there we have it.